Hello and welcome to part 2 of our C-clamp assembly tutorial. So in this section we're going to be going over how to cut out some threads for we're going to tap the block itself through this cylinder hole, and then we are actually going to cut some threads into the screw mechanism of the C-clamp. So to begin, we are going to we have to figure out the pitch. So the pitch of the screw needs to be, so the overall dimension, right? The overall dimension was 16 turns per inch. So what we're going to do is actually, so 1 divided by 16 is going to be our pitch. So to keep it a little bit smaller, we're just going to use the 0.06, and that's fine. So we're going to use the 0.06 to make our triangle, our equilateral triangle, that will then follow our helix and make the cuts. So let's get into it. So what we're going to do now is create a curve, a helix, through this cylinder, through this hole. And the helix is right there. So the first thing, it asks us turns, right? We are going to put height and pitch, because we figured out the pitch is going to be 0.0625 rather, and the height is just going to be how long of a helix we want to make. So that's the first edge. Obviously we want to go the other way with that, and then the pitch is going to be 0.0625, and if you extend it out, that should be okay. So it'll just continue the cut all the way out of there. So that should be okay. And if it's not, we can come back to it and change it. It's 3/4 of an inch, but I'm thinking this way it might continue the cut all the way out of the hole rather than stop the cut somewhere in there. So check it off. We have our helix on the inside. And now, so if we look at where the starting point is of the helix, it's right on the quadrant of the circle here. So what we're going to want to do is create a plane that goes through the quadrant of the circle. And then we're going to draw a triangle, equilateral triangle at 0.06 on the top of that plane. So it's kind of like we're making a cutting edge using triangles, kind of like what it would do, like we're making a cutting edge and then performing the cut. So what I'm going to do now is right click on top plane, and I am going to right click here, click on offset plane, and I want a plane point, and I'm going to click on there, and then notice my plane is offsetted from the top plane, so it's parallel with that, and then it's going up to that point where the helix begins. Check it off. Now we have a plane that we can draw our equilateral triangle on. So click on sketch, click on this plane, and then I'm going to go into a top view, and I want the point pointing outward or upward, so that is then going to follow this helix and make the cut that we need. I'm going to create my line and start with a straight line, straight horizontal, another line, and now I'm going to dimension the bottom here. That's going to be 0.06. And now to make this an equilateral, I got to hit the equal key, and then I'm going to click on all of these. And just make sure that this is horizontal. Okay. Now what I'm going to do is make this triangle pierce my helix. So this pierce, and then this part here, because what I'm doing is I'm making this not tangent, but almost coincide with the helical shape to act like, so this is like my cutting edge, right? This is like I'm gonna put this into my 3D object, and it's gonna cut out that path, and where I want it to pierce is on the helix. And it's okay that it's out here, because it's as if that curve was extended. So once I am there, I'm going to check it off, and then I'm going to click on sweep, and this is going to be a remove, and I need to click on faces of the sketch, and I want to click on my triangle, and then the sweep path is going to be my helix. And check it off. So notice how it did cut in a little bit. I mean, that wouldn't be great if you were machining this, right? You would probably have a nicer cut than that. But for what we're using it for, that's fine. As long as we have those and can hide the curves. So now you can actually see that you made the cut on the inside. And so that's your 3/8 tap, and that's the those are the threads resulting. And these are considered to be V threads, meaning that they kind of, I'll show you V threads. And this is kind of another assumption that we're making, right? It's just like this is like a V thread. So that's why the pitch is equal to that 1 divided by 16, because they equally add up. There are other threads that are not V threads, that aren't perfect triangles, equilateral triangles. Like something like this, right, where you have different, they're not from the top of the triangle to the top of the triangle. Notice the pitch is different. But with a V thread, the pitch is from the top of the triangles. So we are making that assumption that that is the type of thread that we are using. So from here, we are going to move on to the screw. And we're going to do a very similar thing with the screw. And so we're going to make a curve, and we are going to again select the height and pitch, and the pitch will be again 0.0625, and we want it to go the other way. And we can just kind of move this up. And it doesn't have to go, the thread doesn't have to go all the way to the top here. But if we did want to do that, we would just, yeah, that looks good. So about 3 inches. 3 inches will get us all the way up there. So 3 inches is good. And we're going to check it off. And now, so for this one, we already have a midplane. So our midplane is actually our top plane. So we're just going to use that. So we're not going to have to worry about tolerancing with this. That would be something you would have to worry about in the when you're out machining it, and you would have to note it in the sketch. But for this, for what we're doing, we don't have to input a tolerance in when we're making the cuts here with our triangle. So we're just going to use the 0.06 again, and we're going to assume that you can make them equal. But in reality, when you were manufacturing this, you wouldn't be able to make them 100% equal, right? There's always a tolerance on something. So, but in this case, we're not gonna really worry about that. Okay, and I'm just gonna look to see where the end here is, and again, it's on the quadrant, right? It's on the quadrant over there. So I am going to make a sketch on my top plane. All right, and I'm going to make it over in that direction. All right, so make this horizontal. Oops. All right. Oh, vertical. Yeah, it's actually vertical. That's right, because I turned the screen. So, and then I'm gonna dimension this out to 0.06, and then I'm gonna make these all equal. And I'm gonna pierce. And I am going to check it off, sweep, remove. This is the faces of the sketch, and then the sweep path. Oh, and I did that backwards. So I'm glad I kind of did that, because now I can explain. Right, so we're cutting with this edge here, right? So if we're cutting and I wrap that triangle around like so, right, I'm not going to cut anything. So in order to cut, unlike the tap I just did, I need to do make the cut like a die, right? So the die is going to cut the other way into this screw, into this shaft. So again, if I look over here, and then I can, looks like I'm just gonna have to make the other side to this over here. And then I can make them equal again. And now I'm good, because this is still piercing. Check it off. Sweep path, remove. That's the face, and this is the path. And now it's doing what I need to do. check it off, hide my curve, and there you have it. So notice how there is a tiny space here, right? Now that means that this isn't a perfect V, right? That's not a perfect V thread. To make it, you don't have to do this, but I'm just going to show you. To make it perfect V, I would have 0.0625, right? Because that was the actual length, and notice it can no longer do that sweep because the sweep intersects itself, right? That's kind of like when SolidWorks has zero geometry, right? That it's intersecting on that point, so it doesn't have the Boolean logic, doesn't know what to do. So we can't do that. So if I make it a tiny bit smaller, then that should work because I have a little bit where it's not intersecting. And again, like, you're not going to get it perfect, right? Because even a V thread, even the perfect V thread has a little bit there that doesn't result in the perfect triangle. All right, so that's kind of how we are gonna make our threads here. And so the next part of this video series will have us assembling the 3 parts. Thank you for watching, and continue on to the next video.